Okay.
When we start showing slides.
Okay. Why don't we go ahead and get started? Somebody good at whistling? Why don't we go ahead and get started? We have why don't we go ahead and get started? Welcome all of you to the 4th annual Hatfield Marine Science Center Research Summit. Yay! How many of you were here for the first one? All right. How many have been to all 4? A few. All right. How many of you are happy to be here in person again? All right. So my name is Lori Whitecamp. I'm the one who came up with the idea for the summit. And so by default, then I have to help organize it. But Cinnamon is also she's the one who does all the heavy lifting with the organization. Cinnamon Moffat. Yes. So the theme of this year's summit, originally, it was coming back together again to celebrate the fact that we are actually all in the room again. And then as we started talking to people and thinking about what we were going to do with this, we realized this envisioning the future was really a key part of the theme as well. So we're here, we're looking forward. We're trying not to look too hard in that rear view mirror that was pretty ugly at times. So just for logistics, for those of you who are on site, Sin, I'm going to let you do the earthquake thing.
All right, so we are if you are here on site, we are in a vertical evacuation structure. Lucky us. That means that if the ground starts to shake, you will exit out the doors that are hidden behind the curtain or out the doors out here and immediately go up to the roof, and we will be okay up there. So just let you know that this is where we're at, and we've got you if the ground starts to move.
So bathrooms, there's bathrooms around the hall behind you, right behind this auditorium. And I'm sure there's other bathrooms around the building that I don't know about and I have not yet visited, but there's a lot of bathrooms. All the food, hopefully you've seen it over in room 146 over there. That's where lunch is going to be. That's where our break will be, and afternoon breaks. And then if you have questions for the speakers or the panelists or whatever, we need to have you talk into a mic because we have people online and they can't hear you if you're not talking into a mic. So make sure you do that. For those of you who are online, your microphones have been muted, your cameras are off, but you can ask questions through the chat, and we have somebody here monitoring the chat. And please, I know a lot of us have developed really, really bad habits while we're Zoom calls. We all multitask and aren't really paying attention, but we're in person now. You have to remember when you're in person, be respectful, turn your phones off. We will shame you. If I hear a phone ringing, we will gladly shame you. So please engage. Have fun. Okay, most of you have the agenda, so we're going to have some welcomes. Bob Cowan, our fearless leader, is going to give a really great coming back together, envisioning the future talk. And then we're going to have some quick 10-minute talks that will, one session, lunch, energy panel, lunch, second set of talks, and then we'll go into the breakout rooms. So it should be pretty seamless. And then, of course, we're going to have the social at Beer One later this afternoon. So a full day planned. And when we sent out the pre-summit survey, we asked you for 5 words to characterize what you think of Hatfield and what you do. And this is the word cloud that came out of that. And I think it's really interesting to kind of see what the major themes are: ecology, conservation, fisheries management, research, etc. And also to contrast what we saw from this year to what we had from previous years. And I think it's really interesting that climate change has become much more in people's minds this year than previous, where it was techniques, data, ecology, a little bit of acidification in there. So 10 years from now, I think this is going to be really interesting as kind of a track of what we have. Mark Farley is going to talk about what we're the different groups here. But before he does that, I thought we'd quick do another show of hands to give us a sense of how diverse we are here. We have, I don't know how many different federal agencies, state agencies, different branches of OSU that I don't understand, et cetera. So quick show of hands. How many of you work for a state agency? Okay, and that account includes OSU. Okay, few more hands. Okay, how many of you work for a federal agency, since we have some feds on it? Yeah, so we're the ones who aren't here on things like Indigenous Peoples Day or Veterans Day. And all the rest of you are wondering what's going on. How many of you are students? Okay, a few. Excellent. We were missing you guys last night. How many of you are educators? All right, quite a few hands there. And how many of you work on resource management? You're the policy wonk people, okay? We got a few of those. So we really have a diverse group of people here. And with that, I'm going to turn it over to Mark, who's really going to tell you all about it.
Okay, everybody hear me? My mic is working. Yeah. All right. And I'm ready to queue up here. All right. So I am Mark Farley. I'm the Strategic Initiatives Manager. I work with what is known as the Director's Office, which is the OSU group of administrators that organizes the campus that you all work in. And we introduce people to Hatfield constantly. And what I love about it is always the aha, I had no idea tour. So most people have taken their family to the visitor center. They don't know what's behind the scenes. And what's behind the scenes is, we'll talk about that here for just a minute. And I'll spoil the joke. It's all of you. Who is Hatfield? Hatfield is all of us. Hatfield is a collection of buildings on a campus, really the canvas, and you guys are the paint. And so these buildings have been here for a while. This one, of course, is new and has created quite the stir of activity and kind of the ripple effect of change. But a lot of these buildings have been here for a long time, and the work inside those buildings have changed because everyone here, all the scientists, staff, technicians, have changed over time. The work that the world cares about has changed over time. The problems we're solving has changed. So these buildings have really become this kind of palette that everything moves around in. So our campus is divided up into what we call kind of OSU territory, federal territory, and then other state agencies. Really, we are all mingled in and amongst all of these spaces. We have joint positions, we have students, we have staff that move in and out of all these spaces. So while we show this as kind of like the blue territory, the orange territory, this is all of us. And it's pretty impressive. This is 49 acres. It's a big chunk of campus, especially when you think about other university campuses elsewhere in the world. We have OSU people. There's about 200 of us, kind of depending on the season and how many of you are at remote working. And we have about 212 agency folks. Now that, of course, changes depending on who's here too. In the summer, as many of you who get to experience summer around here, we have anywhere from 100 to 200 students on campus, which really is amazing and energetic and great. And then when we add up all the dollars, we have an economic footprint that we bring to this area of between $42 and $50 million, depending on how many of you kind of bag that big grant. So for kind of the OSU side of things, 7 colleges are represented here at Hatfield. And so that means 7 colleges that host and take care of scientists and professors that have specialties. And as you can see, it's quite a range of folks up there. And in fact, we're seeing more and more colleagues from College of Liberal Arts coming out, in part due to all the efforts that the Marine Studies Initiative has put on. Let's see, anybody? Oh, College of Vet Med. For those of you who don't know Tim Miller-Morgan and Carla, there are Vet Med folks that are here. So kind of an interesting animal component that has showed up at Hatfield lately. Another kind of OSU term, centers and institutes. So these are all those folks that we just saw that were in the colleges, organized themselves under centers and institutes, which is a term that comes out of our research office. So it's a group of people that have been organized to do something specific and work in a specific focus area. And we have quite a number of centers and institutes and programs out here, kind of an unusual number for a marine lab nationally. And then all of the rest of you, our federal and state partners, which we have, this campus is pretty unique that we're all here blended and working together. So I love it when folks come in for the first time and they're like, oh my God, aren't you excited that NOAA's here? And it's like, well, NOAA's been here for quite a while. And we've got flavors of NOAA. We have multiple flavors. And so that's always an interesting point of education for visitors that come around and see us for the first time. USDA, we've got a lot of new colleagues come in from USDA that have moved into the East Wing and are refurbishing labs and will be working in our aquaculture study area. And EPA and Oregon Department of Fish and Wildlife, US Fish and Wildlife, all here with us. And hopefully we hear from some of them today. Field and lab experiences. So this is something that's kind of unique to a marine lab and to a science center like us, is we host a lot of paid interns. So research experience for undergrad program, Chung runs that. And that brings a lot of young scientists to the table and working in all of your labs. We're one of the largest REU programs in the US. And that is a program that if all of you had more seats, we could grow. So it's something to think about as you think about kind of offering some of those professional development opportunities for young scientists. Then we have a whole bunch of other interns that are here. And they're coming through like the Hollings funding. They're coming through EPA funding. They're coming through all sorts of other funding tracks. So we host an enormous amount of research experience students here every summer and spring. So all of the undergraduate and graduate students that are part of those colleges and our students taking courses and working here and professionalizing their experience. So we have seen an enormous amount of growth in the last couple of years around the number of students we're hosting on campus. So we're seeing about 110 to 150, depending on how you mix some of those interns in. Visitors and youth. The Visitor Center brings an enormous number of people to the table. And so 150,000 visitors come through there a year. A lot of the demographic surveys that we work on in that space say that 60% of those people are always first timers. So if you think about that, it's like, wow, a lot of folks are touching that space. And then Tracy and the STEM Hub deal with a lot of our K through 12 students in the area. So a lot of hands-on science, a lot of students in those wet labs, career day, homeschool day. It's kind of a phenomenal amount of science programming being offered to the community. Okay, this is my new graphic. We're always trying to figure out how to conceptualize the concentric rings of Hatfield. So there is Hatfield, this campus and these buildings and us, but Hatfield extends beyond us. So it's all of our community partners, our partner universities, all of the agencies we work with, the tribes, our blue sector networks, our state commodity commissions, our fishing fleet, all the partners that when we need to put our hand out into the community and do something meaningful, we have people who pick up the phone. And this universe of ours is phenomenal. And it's what makes a lot of our work so potent, is that we live amongst each other. So we are the science center, we are scientists, but our kids play soccer together. We all see each other at Fred Meyer. We all need a meeting room because we drove from Brookings and God, that's far. We all have interdependence around each other. And that is what is so powerful about this community. We get a lot of visitors coming in from other universities and other science centers. They see this indirectly and they come and ask us, how are you doing this? Like, what have you mandated to make everybody work together? It's like, we don't mandate anything. We just simply rely on each other and we have relationships. So with relationships, I will end there.
Thank you, Mark, for that inspiration. And we really are. I have to say, one of the favorite things I have living in Newport is running into all of you at Fred Meyer's. When I lived in Seattle, I would never run into the people. I even know the cashiers. You know which ones are fast, right? Which ones to avoid. So it is my great pleasure to introduce to you Bob Cowan. Bob is our director of Hatfield, and he's here to give us inspiration about coming back together and envisioning future. Please help me welcome Bob.
Thank you, Lori. So is this enough volume for everyone? Good, okay. So, good morning. It's great to see all of you, to see this so full, even though I got all these lights in my eyes. I want to start though by thanking both Lori and Cinnamon and their planning group for pulling this summit together. I mean, they've done a great job, and I already know it's going to be a huge success, so thank you. In the slideshow, okay. Let's see, what have I done? That's the wrong. See, it wasn't just my fault.
So while we're waiting, I just wanted to point out that everybody that has a blue dot on their name tag is a member of the steering committee. So can you guys raise your hands? We had a great group of people that helped influence and form this, as well as input from both the post summit survey last year and then the pre-summit survey this year. So those are really, really important. So thank them when you get the chance.
Thank you. Okay. Well, today's summit theme, we've heard of it, is coming back together. As we come back after a long hiatus from the COVID pandemic, it's affected us. And today we're going to be talking about some of the challenges we have in coming back together and envisioning a future that maybe is the same. Certainly, as Mark was just giving us a good view, it's a spectacular community that we have here. But here's an opportunity to envision something different. So it's where we build on the past and look to the future. I kind of think we've been here before, but it is a exercise that we really need to put some thoughtful time into it. And I'm sure that there's, during the COVID period, you've read articles, you thought about, well, what is the new meeting going to be, and all things like that. I want to think about this holistically. So to say that, to start, welcome. This is the first start of coming back together, is being together in the same room. So we're coming out of the COVID era. We're not out of it. There's still going to be some of it with us for a while, unfortunately. But I would say that this event, this pandemic, is probably the single largest impactful event that we will encounter in our lives. Certainly, if any other negative things, I hope we won't get anything to this level. It challenged our ability to interact face to face, this personal touch here, which is really important. And it took a lot of perseverance to get through it and to get here. And with that, I want to thank all of you for your perseverance. It was quite an effort, but we made it. We're very fortunate that today's technology enabled us to keep in touch. We all love to hate Zoom, but it was critical in our ability to stay in contact. but it still did not give us this face-to-face human interaction that we really need. It's critically important. It's been a long time coming back, but I think we're doing that. I think we're starting to see more people getting together with friends and family, more recreation and more work. And that's really important. In fact, examples of that, last month at the picnic, we had 245 people. That was huge. It's twice what we normally have. And just a couple of weeks ago, the Marine Mammal Institute had a donor event, and they had over 200 people there. And then look at this. This is tremendous. This, again, our largest summit. So we really are trying to come back, and I appreciate that, and I just say welcome back. So the steps now are to move forward, and how do we do that? What did we learn from COVID? What were we thinking about all those times when you were sitting in your little home office by yourself, thinking about, well, what do I miss? What would I like to see? What's coming? Keeping that in mind, thinking about some of those things, we have an opportunity to break with the past. Not that all the past is bad, but there's some things that we could probably do without. And move forward thoughtfully. Now, there have been a lot of changes going on, changes in our own lives, of course, but changes at Hatfield. And we need to think about all of those as we try to envision where we're going, keeping all the opportunities in mind. So while you were away, things kept going on here at Hatfield. And I want to run through a little bit of a list of some of this, because as I started gathering it, it became pretty interesting that when you think about where we've been, who would have even imagined that we'd be here? Now that's a long time span, 50 some years, but let's kind of envision at least the next decade of where we want to be. And it's not just the buildings and the facilities, it's the people, it's the science that we do, it's the impactful connections with the community. It's the education that we've provided at all levels. And that growth and that impact is what we want to continue to inspire. So while you were away, a variety of things happened, both with our facilities and with personnel. And I want to kind of list through that, because I actually, as I was starting to build this, and I've talked about some of these individual snippets in my lunchtime talks, but it was kind of exhilarating to see all that's going on. And I just want to go through it. So Zoom is not our technology, but as I mentioned, it definitely entered into, as a technology, into our lives with a bang. And it's going to still be here. It's going to influence our meetings. Are they going to be in-face meetings? Are they going to be hybrid? Or are they going to be completely digital? And all of those are now a possibility to us. And so we have to kind of keep that in mind. We have this new building here, bright and shiny, the Gladys Valley Marine Studies building. While the work of this building, to building it, started before the pandemic, it was completed during it. And we in fact moved in at the height of the firestorms and smoke that we had. And there's Sheena out there directing traffic. It was pretty amazing to do this with most people gone, or they'd come in individually to pack up their labs and offices. But we moved everything in about a 2 to 3 day period from across the campus. And that was quite an effort. And here we are. We've got this, as I said, this great facility. So let me go through some parts of it. First of all, the Innovation Lab. This is something that's really unique. And we have this. It's a makerspace on steroids. And it gives us the ability as a community, as scientists, as educators, and as students to innovate, to advance our sensors that we use in the field or the different techniques that we do. If we're going to be state of the art, we need to be able to create some of that. And this gives us that ability. If we don't know how to do it, Drummond, the manager, wherever Drummond is, there he is, can help you. He'll teach you how to do the tool, use the tools. He can help advise. He can even do a lot of the work if necessary. But this is a tremendous advantage to us in the work we do and the education that we give. This auditorium, of course, is great. Look at it. We're able to now have large numbers of people, science-related classes, meetings. We can have conferences here, but we also have a much better opportunity to interface with the community, even on non-science things. Our classrooms, we have several new classrooms here that are giving us an opportunity to teach in slightly different ways, a little more give and take, a different pedagogy that really is a lot of potential opportunity there for those who want to grab it. And it adds to the classrooms we already have, those that are fitted with seawater as well. New laboratories in this building. We're trying a more open, shared laboratory approach, trying to encourage interaction with people, different disciplines together, allowed to grow or shrink as your funding does, without feeling that you're losing permanent space. And then, as already mentioned, we have the vertical evacuation. We have a sense of security given where we work. And this vertical evacuation and the cache of supplies to support us is just something to keep in the back of your mind, that you can breathe a little bit deeper. And we have a cafe. My first day on the job here, people said, how can you get some work, some food here? Finally we did. It took a while, but I'm pretty happy with that. And as more of us come back, that will help to sustain it and add diversity to it. So kind of keep that in mind, but it is great. So other facility sort of things. Our IT has been continually upgraded, not just in this building in that sense, but the main fiber, the dark fiber. We have dark fiber now, a term that I still don't know quite how to define, but I'm going to use it, that connects us to Corvallis and to the greater university network. This is over an order of magnitude faster connections than we've had. And so that enables us, instead of having to drive our hard drives over to the main campus to upload them into the computing facilities, we can just do it directly over line. And the university IT and the state have combined to get us that at no cost to us. And now we had a couple breaks. They're now adding in a alternate route, so we will have duplication and we won't have any more breaks. So quite an investment in us, which is great. IT is also invested in our academic technology. All of our classrooms now and conference rooms have state-of-the-art communication ability, including in our teaching labs. We have these small cameras which can work as a microscope or cover larger areas of the tanks, all the way to this, what we're looking at right here. So we've really added to our academic capabilities. Our seawater system's been upgraded. The causeway's been replaced. The pumps are, it secures going forward in our ability to provide high quality seawater to the laboratories. It also is going to have a climate monitoring station associated with that. And Cinnamon has been important in getting some of the funding for this, but we're working with the US EPA and private industry in pulling this together, a nice partnership. And so that's, and it also have a place where you can experimentally test new sensors. This is not a really big one, but it is important to those that it matters to. We're upgrading our outdoor storage, our boat area. It's being paved, it's being enlarged, it's going to have security fences now. So it's really important, the other thing I hear besides a cafe is we need storage. And so this is an effort to have storage for outdoor field equipment and large boats, large and small boats. College of CEOS is working and starting very soon on the replacement of the ship ops pier, upgrading the whole pier structure for arrival of our newest vessel, the Tawny, which is coming, I think, in 2024 is the hope that it'll be here at that point. And that's another big investment that both the causeway was about $5.5 million, I believe. The pier is another $5 or so million that the university is investing in Hatfield. Housing, I'm smiling. We have finally on the street an RFP for a design build contractor. And in fact, tomorrow, the review committee is meeting to choose that contractor with the hopes that we can start breaking ground in the spring as soon as the heavy rains are ending. So by the end of the year or very early the 2024, we will have new housing. It won't be, it's the first phase, but it is where we've been trying to get for quite some time. And finally, we're not forgetting our original buildings, which the 900 building needs major upgrades and renovations. It's got to be brought into this century. And so we have now a commitment from the university to not only do energy efficiency to it, upgrading the HVAC in it, but also renovating a lot of the laboratories and also moving the facilities shop out, building a new facilities area for that and turning that into a shared seawater lab. So a lot of additional investment to keep in mind as we're going forward, what's available or will be. Now, the other asset is, of course, our people. And in fact, this is the bigger asset. We have a tremendous group and you all are part of it. And since 2019, since late 2019, we have probably around 50 to 55 new people here. I'm going to highlight the faculty and the PIs to try to keep this list manageable. But each PI that comes in brings postdocs and FRAs and graduate students. And so you'll get a sense of what we're experiencing here. First of all, I find this remarkable is that the directors of MMI, Simmers, Oregon Sea Grant, and searching right now for Coombs have all changed. And we have new people in those positions since 2019. In fact, I think Lisa Balance arrived a day or two before the 2019 summit. Also, all of our federal labs have new supervisors or directors or heads. They're all called something different, and I can't remember exactly what they all are. But in NOAA, it's been Aaron Berger and Mary Hunsicker have been taking interim positions for that. The US EPA, we have Matt Harwell is here. US Fish and Wildlife is Harry McQuillan. I'm not sure if I saw Harry here. And USDA, our own Brett Dumbald is acting in that role. So this is pretty exciting to have that much turnover in leadership. And I must say, I'm very impressed with all of the individuals. They bring in a lot to us. If we then just sort of go through some of the people, I'm not going to talk about each individual, but we see some significant growth. MMI has really taken off since I mean, it was already a super power in marine mammal research with Bruce, but now that Lisa's here, she's really taken it up to another level, and this is great. Francis with Simmers. Again, our Coombs, Suzanne Brander was already at OSU, but she's moved out into our group. Taylor's here. Oregon Sea Grant, CEOS, iLab, STEM Hub, new director there, Cynthia. And some of you may or may not know, USDA ARS has decided to expand their program here, expand their aquaculture program. And there are so far 2 new PIs, but there'll be a 3rd one coming in to work alongside Brett. As I mentioned, EPA, Matt's here, Harry McQuillan with US Fish and Wildlife, and then our own staff. All of this since 2019, late 2019. So it's a tremendous aggregation of people that have come to Hatfield and bring to us a lot of energy. They bring a lot of excitement, new ideas, new possibilities for collaboration. So opportunities, opportunities, opportunities. So as we go forward and think about coming back together, we need to step back again and think a little bit about where we've been, what's been happening in the intervening period. That includes new directions of science, new issues that are really important. Where and how do we utilize all these changes as we vision the future? So a couple just parting thoughts on this. How has the educational landscape that's changed, the changes that are going on, whether it's the technology of academic technology or classrooms that enable more of a group working approach rather than the lecture, how do we capture that and how do we work in that space? I encourage particularly the younger, newer faculty to embrace that and turn it into your new mode of teaching so you can be more impactful. What have we learned from the pandemic? Well, we've certainly learned that we need to focus on science. We need to focus on facts and truth. And unfortunately, we need to communicate that in a way that rebuilds trust. This is not anything that's really specific to our community as marine scientists. I think we still have the trust of our community, but at the larger scale, this is something we all need to contend with, unfortunately. But I have no doubt that we can do it well. We can certainly talk about the impacts of our work, and our audience, our community will easily understand how it affects them. So what does the future hold? It's yours. It's not mine, it's yours. You need to think about it. You need to make it. And I will end by saying, as you're doing that, be aspirational. Really think, where do you want to be individually and as a community 10 to 20 years from now? So with that, our future is bright. Just grab it, be part of that future. Thank you.
Thank you, Bob. And we have time for a quick question. Does anybody have a burning question for Bob? Or online? Nope. Okay.
That's fine. Good. It was going to be too esoteric, I'm sure.
So now we're going to move into the first series of research talks. And this is really, the intent of these talks is really to highlight some of the really amazing work that goes on at Hatfield. And this year we selected people who we thought are either doing really new and innovative stuff, or perhaps are working on existing programs that have been existing for a long time and nobody really knows about, that they're under the radar and really shouldn't be, because they're things that have huge opportunities and we should celebrate going forward. So our first speaker is Lindsay Aylesworth, and she is going to be talking about Oregon Marine Reserve. So please help me welcome Lindsay.
Hi, everyone. Can you hear me okay? Sounds great. All right. So some of you may be familiar with our program, the Oregon Marine Reserves program. Now that I've listened to Bob and others speak about change, we've had some changes in our program too, but I thought I'd give a bit of a kind of a background refresher in case your mind hasn't been thinking about the world of marine reserves like mine has for the last several years of the pandemic. So we have 5 marine reserves here in Oregon. Those are places in the ocean where ocean development and fishing is not allowed. You can see them in red over here on the side of the map. Most marine reserves are also surrounded by marine protected areas, which are places where, again, there's no ocean development, but there is some, but not all fishing allowed in these areas. And why do we have these areas here in Oregon? We put them in place for 3 different goals. One is for the conservation of habitats and biodiversity. The second is for these really to be a place for research and for research to inform nearshore ocean management. And the third was we wanted to focus on communities. So trying to make sure by putting these marine reserves in place that they weren't causing any harm to ocean users or coastal communities. The marine reserves in Oregon came from a variety of legislative mandates dating back to an executive order in 2008, which basically tasked ODFW as the main agency responsible for the marine reserves. We had a couple of legislative bills that provided funding for our program and the positions, and also the Ocean Policy Advisory Council, or OPAC, provided different policy recommendations. And these are what really guide what our program focuses on. So they provide the funding for our 6 interdisciplinary staff and the funding for research for our program as well. So with our 6 staff, we focus on creating management plans for these areas. We have 3 staff dedicated to ecological monitoring of the biological communities. We have 1 staff member whose goal is to try and understand the socioeconomic impacts of putting these marine reserves in different communities of interest and communities of place. We have a person whose job is dedicated towards outreach and community engagement. And then we also work with various partners on compliance and enforcement. And so that compliance and enforcement piece, we partner with other agencies like state police and state parks here for that aspect. But for a lot of our research on both the human dimension side and the ecological side, we partner with a lot of different groups to collaborate to get our research done. A lot of those collaborators are actually here at Hatfield and at OSU, again, both with our ecological research and for the socioeconomic research. So for our ecological monitoring, again, just to help think of maybe possibilities for collaborations in the future, we have kind of 4 main tools that we use to gather data on really a variety of different components of the ecosystem. So fish and invertebrate communities. We do research on the algae and the benthic habitats in these communities. And we do research collecting data on oceanographic conditions. We also partner with various groups here at OSU, again, to focus on oceanography, to focus on studying intertidal habitats, and also to look at juvenile fish research. So for the ecological monitoring, we're doing monitoring at 14 different sites up and down the coast. On one side here is kind of the northern coast of Oregon. You can see Astoria, and then down south past Port Orford. And so we do our monitoring in the 5 marine reserves and 9 different comparison sites. So there's lots of data sets available to ask different questions about how these communities are changing over time. For our human dimensions research, this really focuses on understanding the socioeconomic aspects of the different communities on the coast, of different stakeholder groups, trying to understand what these communities look like, and then also trying to understand what the impacts are of putting marine reserves in place. This program also allows us to be able to understand different communities' support and attitudes towards the marine reserves and see how they change over time. So I'm going to go back a little bit to one of the legislative bills that helps guide our program, and that's because that is what we have been working on during the pandemic. So back to that Senate Bill 1510, it states that there'll be a programmatic check-in of the Marine Reserves Program by the legislature in 2023. So you can see the timeline here of our program. Our program really spun up in 2010. We had some of our first harvest restrictions at 2 of our first marine reserves going into effect in 2012, adding in additional marine reserve sites. And you can see 23 check-in is just around the corner. So during the pandemic, part of the task of our program was really to focus on writing a report, highlighting all the different things that we've learned in the first 10 years of implementation of our program. What have we learned on the ecological side of things? What have we learned in terms of engaging with different communities and outreach and awareness? What are the different impacts of our program? So a little bit about some of the COVID challenges that we faced. We still had 1 year left of field work that was supposed to go into that report in 2020. So in those early days, just like many of you, we also could not have staff out in the field, but we were able to focus on ways to work with other partners and collaborators, including the fishing community, at times to be able to get out and get certain aspects of field work done. We also have a lot of field work that relies on volunteers to help us collect data. And so, as you can see, several of our surveys did not run because of the different struggles with the COVID pandemic and having a lot of volunteers helping collect research. But for some different aspects of data collection, we were still able to move forward with data collection. But one of the great benefits of COVID was really allowing us the time and space to focus on data management. I'm going to call it the non-sexy side of doing a lot of science, right? And so, you know, we so often focus on all this data collection. Yes, let's get the data, let's get the data. But then you need to take that data and turn it into databases. So that way we can analyze the data and then write reports to be able to share the cool stories about what we're actually learning. And so during the COVID period, for example, we went through 14 different ecological data sets, making sure the data were available for analysis, building out different databases. And we wrote a lot of different reports, sort of that are technical reports to this main 10-body report that we worked on. On the socioeconomic side of the house, because that was just ecological, again, we're talking about 34 different socioeconomic studies that were summarized and really coalesced to be able to tell stories about what we're learning. Lots of different analyses, lots of different reports happened. And so all of that really couldn't have been done without kind of that time away from fieldwork to focus on those other aspects. A benefit was that we were also able to have discussions with some of our academic collaborators about data analysis and report write-up. Oftentimes we get so excited collecting new data together, we don't talk very much about, about the data management and when are we going to do analysis and write up those reports and where's that money going to come from to fund people to do that? Okay, so what have we learned? Drummond, I think I don't have a lot of time left. Okay, I've got less than 1 minute. So I can't tell you very much about what we've learned, but if you come to the State of the Coast conference on November 5th, I'll be giving a speaker presentation there about what we've learned from the past 10 years of Oregon Marine Reserves. If you can't wait until then, you can either come find myself or one of my teammates, or you can visit our website where we have a couple of different one-pagers that are kind of quick takeaways about what we've learned from the 10 years of our program over the last couple of years. So I think I'm right at the 10-minute mark. Thanks for your attention, and we'd welcome some more collaboration.
Thank you, Lindsay. And we do have time for a question. If anybody has a question they want to ask Lindsay coming up. So if somebody had wanted to work with you guys on your reserves, who should they go to? Say they want to go and look at the fish out there.
Great, come on and talk to me.
Lindsay.
If you have questions about anything, come find me. We've also had some transitions in our program, but I am here ready to talk about collaborations in any sort of aspect that you are interested in.
Excellent.
So bring it on.
Great. And it seems like an excellent opportunity.
Yes, question.
Use a mic.
Not a question, but more of a statement. And Lindsay, what you just stated just now is really what makes this community so strong, is that everyone is so approachable to do collaboration. You are in fact able to connect with that lead and have a discussion about collaboration at one of the highest levels, which is really tenement to how great this community is.
Here, here.
Yes. All right. Go Hatfield. Our next speaker is Francis Chan. Francis is a professor of OSU in the Integrative Biology Department, and he is also the new head of the SIMMERS program. And I'm going to let him tell you what that acronym stands for. And he's going to be talking about collaboration opportunities. There it is. So please help me welcome Francis.
Good morning, Hatfield. It's so fun. I get to use my arms when I talk. It's awesome. So I'm Francis Chan. I'm the relatively new director of SIMMERS, which is the Cooperative Institute for Marine Ecosystems and Resources Studies. That's half my job. My other half of the job is an OSU faculty. So before I get into collaborative science, well, what is SIMMERS and why do we exist? Well, we're one of 16 cooperative institutes around the nation with NOAA. And basically, NOAA realizes that to satisfy its agency mission needs, so these are 3 of the agency's priorities, and I've paraphrased them: climate ready nation, equity, stewardship, and new blue economy. To achieve those goals, they realize they need a lot more science than they have in-house. So Cooperative Institute is a mechanism for NOAA to access that kind of expertise. And we're fortunate enough to be one of those institutions. And collectively, the Cooperative Institute Network administers about $250 million in internal NOAA research dollars annually. So this part, the internal part, is really important because this money, it's never on the street. You don't see it in a competitive RFP. So these are internal NOAA research dollars that are a task for collaborative research. And you'll notice that where we are, there's 2 Cooperative Institute. Well, the previous incarnation, SIMMERS without the E, that was led by my predecessor, Michael Banks. We competed for it. It's been at OSU as a partnership for over 4 decades. So I think that speaks to the strength, the longevity of that partnership. And OSU and NOAA, we're not strangers because we are a source of workforce development for them. OSU has given NOAA 3 of its 11 administrators. Now, what is it that we do in SIMMERS? When we were competing for this Cooperative Institute Award, we were given 4 broad lanes. They're conservation, protection, and restoration of marine resources, marine ecosystems, ocean acoustics, ocean, coastal, and seafloor processes. And I have some pictures that describe it. So it might be a project looking at salmon genetics or salmon bycatch and hake fishery, marine ecosystem. You know the team that goes out continuously to give us this information about how the North Pacific is changing. We're also home to the NOAA acoustic program. So working very closely with Bob Ziak, OSU researchers, really are the ones that are putting out the sensors for the noise reference network. And we have an amazing team that does crazy cool ocean exploration research. But I think it's important so this is what NOAA wanted to do when they put up the RFP for Cooperative Institute. And this is what we view as our mission. And it's really to provide solutions. It's about climate change science, readying ourselves to climate change. It's about expanding science to meet the demands of ocean uses that are in the pipeline. So the blue economy that we're facing, but also equitability in training and management. So climate radiation, blue economy, and equity in our field. So those are reflected in the NOAA priorities. And of course, I cheated because Rick Spinrad helped me develop these before he left and went to head NOAA. And who is doing this work? And these are our Simmers people in their happy places. So it might be Sam at sea and looking at sea pickles, Samara deploying hydrophones, Jay, professional faculty in his workshop, and Tamara getting ready to take some more gas samples. So these are people that work within Simmers. You might know some of them, but introduce yourself. Sometimes they can be squirreled away in the NOAA building. And what does collaborative research and training look like from our perspective, from Simmers' perspective? And I'll just say that it can't look like this. It really can't look like this. And you know, you've been that guy, right? You've been that guy where you're like, oh, what are we doing here? So I hope that that's not where we're at. And I'll try to walk us through by first saying, well, who are we working with? You know, what's the nature of the OSU NOAA collaboration? And we have, in a sense, clients, built-in clients for our recompete. There were some designated labs and centers that we are to work with. It starts at the National Marine Sanctuaries Program, PMEL, Northwest Fishery, and Alaska Fisheries. So those are the people that we work most closely with. And in fact, our researchers are really embedded in those research teams. But while these are key partners, they're not exclusively so. So we also can work with other NOAA line offices to access that internal funding. And what is NOAA research? And I'll stop, and I apologize for people, my NOAA colleagues and my Simmer colleagues. This talk is not for you. You can check your email. But you know, broadly, what do we mean by NOAA science? Is there something special or different about it? Yes and no. And you've all seen this, I'm sure. This is the Pastor's quadrant plot where we look at this two axes, this biplot where, you know, is the science relevant for application? And you can really max that out by, you know, very, very innovative applied science. So that's the Edison quadrant. Or you can really have science that is innovative, basic science that's fundamental and changes our understanding of nature. That's Bohr's quadrant. Or you can be working in the Pasteur's quadrant where you're trying to do both things. And that I think is really important. NOAA science really spans that, but the sweet spot is really in that difficult to reach pinnacle where you're really advancing both application and basic science. And this was used by Rick Spinrad to communicate that work. And of course, this bottom quadrant is called the Chia Pet quadrant, which is not innovative and not really useful. But and I should say that, you know, if we do this well, this use-inspired research, it can help us to get other research opportunities. For example, this is Rick Spinrad on Twitter. They just NOAA and NSF signed MOU to really advance this kind of science between the two agencies. So what are we collaborating to do? I made up this list last night thinking about what are the things that we as a community, or certainly us within Simmers, are hoping to make headway on. is certainly making our community, our research community, a more diverse and equitable and inclusive field. It's about growing equitable climate solutions. It's advancing the blue economy. It's climate ready fisheries and ocean management. It's realizing the right marine renewable energy future. It's protecting marine mammals in an ocean of really growing uses. It's enhancing ocean literacy. It's innovating ocean research and observing technologies. So, I mean, this is a pretty big list. And if we were to open it up, we would double or triple that list. But it's daunting because, even though we're partnering with a federal agency, this is a lot. This is a lot for us to try to accomplish. So how do we do this? Well, we try to make headway by working in this collaborative research and training landscape. What I mean is that, so OSU, I was looking up numbers, about each year, maybe 8,000 students apply to work with us to be undergrads, and probably another 1,000 plus students apply to, well, maybe even more than that for grad students. So we're an institution where people from across the state from very diverse backgrounds are coming to us to work. So we're a conduit for increased participation in ocean sciences. We should not forget that. So for us to realize that, it means working with programs like the LMR CSC that Jessica heads locally. It might be working with MSI so that we are developing the right kind of courses and opportunities to engage these and get them to the coast. Or it could be about getting the right kinds of technology. It might be working with the Center for Quantitative Life Sciences to advance our AI tech capabilities. And of course, we have partners in Sea Grant, and that is really helping us to think about how do we engage research. So we can't do this alone, but luckily what we do is absolutely a part of this landscape, and we have a niche, as every single one of these institutions have a niche. Okay, but let's say you're keen to dive in, like, where's the money? Is there any money in it? How do we get more dollars to get this work done? And this is a spectrum, and it starts with really year-end money. So if you're you're working with a federal partner and he or she has year-end money, well, that money goes back to Treasury. But they can move the money, well, to an OSU account. So yes, I am the clerk that's going around the store changing the expiration date on money. But that allows you some space to try to innovate with some new collaborations. Or it could be PI project dollars. So there's a PI at OSU, at NOAA, that has budgeted or internally competed dollars. You might be part of that competition team. You might have program dollars at the Lab Center. So our Earth-Ocean Interaction program has been here for decades, and it's a long-term supported program by PMEL. Or there's target federal appropriations, where we work with our government relations office to ask for federal dollars. And for example, our NH line is part of that ask. I'll stop and say that we're here to help. We have new people like Jessica Garwood and Josh Stewart that are also ready to hopefully engage in that collaboration. Thank you.
Thank you, Francis. We have time for one quick question, and there's also a breakout room that are going to be on Simmers and where to go with it. We have a question in the audience for Francis. Nope. Okay. Thank you, Francis, for that. And I look forward to some really interesting discussion this afternoon. As I mentioned, one of the focuses of the talks we had today was programs that have been kind of under the radar. And I think one of those that occurs in the Barry Fisher building is the Observer Program. So we run the West Coast Observer Program out of the Barry Fisher building. And Krista Callway, my colleague who also works with me at the Northwest Fisheries Science Center, has recently taken on the position of leading that program, and or something like that.
We'll go with that.
We'll work with that. So it's my great pleasure to introduce Krista to talk about the Observer Program.
I am so pleased to be here to represent one of the flavors of NOAA. And that's not supposed to run. So just so you know a little bit more about me, so I am here with the West Coast, right? So I'm now here with the West Coast Groundfish Observer Program. And I started way back when, I don't want to say when, but it was a while ago as an observer myself up in Alaska, and I was on groundfish, crab, and I also observed in the salmon fishery. And then I had an opportunity. I transitioned over to NOAA with the North Pacific program, and I was in Anchorage until 2011 when I moved down here to Newport. And obviously, I really do like this kind of work because it's been 22 years and counting. So the Observer Program is part of the Northwest Fisheries Science Center. And as Lori mentioned, we're over in the Barry Fisher building. Our official name is Fisheries Observation Science, and that's a little weird, but the reason is because we actually have two different observer programs within that. And another goal of this was to talk about our partnerships and collaborations. There is nothing more integral to our program than our participation with the Pacific States Marine Fisheries Commission. Our program started in 2001. That was after the fishery was declared a disaster, in cooperation with Pacific States, and we've been co-managing it ever since. And in fact, about half of our staff are Pacific States and the other half are federal. I mentioned these two programs. So one is the At-Sea Hake Observer Program. So these folks go out on those colossal ships, the ones that are 200 to 300 feet long, that are mothership vessels that will just collect catch from other boats all day long, or catcher vessels out at sea for hake. And then the other program is the West Coast Groundfish Observer Program, and that's the one here. Our headquarters is down in Newport. For that program, I'm sorry, we have offices in Seattle where our program managers are in the hake program. We have staff in Astoria, Newport, we have 7, and this is where we do all our training and debriefing. And if you're on campus, you've probably seen us running around at some point. We have staff in Coos Bay, Crescent City, Eureka, and Morro Bay. So we cover a lot of coastline. All in all, about every year, we have around 122 observers that pass through. They're either trained or they're briefing, and we cover about 5,000 days at sea. I can't talk about what fisheries we cover without mentioning the Catch Share program. That was a trawl rationalization program that started in 2011. And what it did is it took this IFQ, this individual fishing quota, and it made it a tradable share. So the participants in that fishery are going to be debited for that, whether they land it, meaning they bring it in and sell it, or if they discard it at sea. So in order to make sure that everything is accounted for, there's 100% coverage required on these boats, either by a human observer or electronic monitoring. And you'll see these numbers are all pretty close to 100. Unfortunately, folks do get sick and injured on occasion, and that's why you might see something dip a little bit lower. Our other fleet that we cover is in the non-catch share program. And these coverage rates, I just want to point out, are a lot lower. So this one is not managed for quota management. It's for the overall management for the fishery, which is done based on landings. And we prioritize this based on what managers need. Limited entry stable fish, for instance, has always been a high priority, all the way down to some that are much smaller, and sea cucumber trawl has been covered, but there's not even enough participants to say what percentage it is. The non-catch share program, this one, they're only out there for a certain amount of time. So it only covers a bit of the fleet, and that gets extrapolated up to the rest. So who are these folks that go out there? In general, they are early career. So they're recent graduates. They have to have a degree in the natural sciences, and that has to include extensive use of dichotomous keys in at least one course. They need to have an undergrad math and an undergrad stats class. So once they're accepted, though, they have to go through a rigorous training. And I did say they're normally early career, but I will mention the bottom right photo there. That is Steve Todd. He's an observer down in San Diego who was in our initial training in 2001, and he's still observing. He's one of 2 observers who's been with us for over 20 years. And I think the further south you go, the longer they stay. So there's a correlation with sunshine. It's called a 3-week training, but really it's boot camp. It is intense. Some of these folks, their degree might not be in fisheries. Most folks have never even been on a boat, and certainly even fewer have been on a fishing boat. So think of the learning curve with that. Then they also need to be able to identify anything that comes up to either species or family level. So there's a lot to learn. And safety is always our top priority. We spend about 24 hours teaching safety skills, and they have to demonstrate all of those. And then we also cover those in their annual briefings. So life goes on even through a pandemic, and so did our program. We had to adapt to it like everyone else did. Our trainings, which as you can see, used to be very in hand. You know, we have these weighted stuffed fish, we have mock trawl practicals. We had to reimagine it, and we went to a hybrid model. So we had 2 weeks of putting everything we could to be remote, and then a week to do those safety skills that you have to get that muscle memory for, and that lab time, because you have to have a fish in front of you. And I'll say on our first training, on the second day was when the fires hit and the cable for the internet got cut. If folks remember that, I do. I was in class. And if there's one thing you learn being an observer is being adaptable. And we had to pivot to a conference call and walking people through PowerPoints, but the show must go on. What are we training them to do? Well, protected species are always going to be a real high priority, and we want to know as much as we can, whether there's sightings of them, there's an interaction with the vessel, or a mortality or a take. So those are our marine mammals, our seabirds, our sea turtles, salmon, green sturgeon, eulachon. We collect fishing effort information. Obviously, we need to know who is fishing with what gear for how long. And then we make catch estimates. For every haul, we know how much was caught or discarded. That's what's not brought back. We're going to focus their energy and effort on the discards, because that's what's not coming into to land. So the observers have a variety of ways that they can sample the catch with a complicated duties and priorities list to put most of their energy and effort towards those protected species or those priority species, like those 63 IFQ species that we need to know where every pound goes. They're also going to collect biosamples. So we take lengths, some otoliths, fin clips, things like that from individual fish. And then we have some collaborative projects. And this is where I'll also make a pitch. So if you want any fishery dependent data, observers are a great platform for that. And we encourage that kind of collaboration as much as we can to enhance science. And don't worry, they did not give me an hour to go over this. I just wanted to give a shock and awe slide of all the different partners and collaborators and data users we have. I would hasten to bet that a lot of folks in this room have used Observer products at some point. We are partners with other federal agencies, with the states, nonprofits, universities. And a lot of our products are actually going to be fed into the stock assessment and to the council. And how is that? Well, it's through our primary reporting. So our annual reports include the groundfish total mortality. That's looking at all the things that are discarded. Those are things, again, not brought back, and all the things that are retained, landed, and end up on a fish ticket. Also come up with a bycatch estimation mortality for Pacific halibut, marine mammals, seabirds, turtles, salmon, green sturgeon, and eulachon. And then that catch share program that I mentioned, that data is updated every week. The observer is going to enter their data really quickly, it's uploaded, and fishers can look at it in almost real time to try and track their quota. So of course, questions, feel free to reach out to me, to my boss, John McVeigh, any of my colleagues who are in the room, and Kate might be surprised to see her name, but she's our analyst here in Newport, and I know she's known to a lot of folks. And of course, I also have to thank all the observers who are working hard at sea, and then all the other fellow staff who I stole some of their slides and material.
And we have time for a couple questions, if anybody has any. And I have to say, the collaborations are fantastic. I have the world's largest collection of ocean caught Pacific lamprey in my freezer that came from a shop, the hake fishery, that would not be possible to get that much. And they're great samples, and it's been really wonderful. Questions for Krista? So Krista, you mentioned that undergrads, is there a website? Do you hire people at a particular time of year, or is it throughout the year that you take people on? How does that work?
Thanks. I should mention that. So our observers are actually independent contractors, and they work through an observer provider. So through our website, you could find an observer provider, you apply through them. And then our trainings are generally like February, March, May, and occasionally in August.
Great. So hopefully undergrads out there, I have to say that if you have somebody who's applying for a job and they have observer training and they were successful, hire them. They are fantastic people to be out on the ship. So thank you, Kristen. Our last speaker in this session is Suzanne Branner. Suzanne works for the Oregon Department or Oregon State University. And she's a toxicologist and will be talking about tire crumb in our waterways. So as soon as she gets upper, please help me welcome Suzanne.
Great. Thank you so much. Can everyone hear me clearly? Wonderful. So I realize this isn't the most uplifting topic, so my husband told me I should make a pun, and so this is my best attempt. So the fish are, haha. Anyway, but tire particles are what I'm going to talk today, and I'll also kind of differentiate between tire crumb and tire and road wear, because tire particles kind of come in different flavors, so to speak, at least for the fish. And I'll be talking a little bit more broadly about being part of COOMS, which it's been such a fantastic move to come out here from campus, such wonderful opportunities for collaboration, which everyone's been talking about so far this morning. And I'll talk about all of the wonderful students and staff that help do some of the work that I'm going to quickly go over today. So most of my talk today is going to focus on work that we've done in the lab and as part of a group called the Pacific Northwest Consortium on Plastics, which is a National Science Foundation funded group in collaboration with my great colleague on campus, Dr. Stacy Harper, who's in toxicology and engineering. And so overall, we've been looking at lots of different plastic types, tire particles being one of many, and using model freshwater organisms or model coastal and estuarine organisms, which I'll focus on and is my group's research focus, to look at impacts of plastics. We know they're out there, we know they're everywhere that we look for them, but why do they matter and what are they doing to the fish and invertebrates that are exposed to them? So, and this is a little bit small, but kind of gives you an overview. We know that plastic waste generation just keeps going up. We know that if we continue to produce plastics at the rate we're currently producing them, we're going to reach about 20 million metric tons per year by 2030, which is only 8 years away. And so there's a lot of discussion, which is encouraging at the UN level. And there's even been discussion of putting together a binding plastics treaty by 2024 to try to reduce some of these inputs. But in the meantime, things like packaging, textiles, and tire and road wear are thought to be the highest contributors to plastic pollution, as well as when we look at microplastics, what we're seeing in the field is a lot of microfibers, and in sediments, a lot of tire particles. Those are kind of the two big ones in coastal areas and freshwater areas as well. And the other thing I like to emphasize about microplastics is that they come in so many different types and combinations. And so when you're thinking about studying microplastics, it's really a giant suite of contaminants. It's not just one type of pollutant. So saying you're going to study microplastics is like saying you're going to study pesticides. There are so many different kinds. And so I think this graphic kind of puts that into perspective. You're thinking about the polymer type, what product it's coming from, what the size is, what the shape is, as well as all the different additives and other chemicals that are used to make it. So what do we know about ecological impacts? We know a lot more than we used to. And a lot of talks refer to microplastics as being this new field, it's a new pollutant. We know it's been around for a long time and it'll be around for a long time after us. But what we do know now, after about a decade or so of studying these particles, is that size and shape is really important. So things like fibers and irregularly shaped particles are more toxic than things that are smooth. Makes sense if you're thinking about ingesting it. They can cause oxidative stress. And one of the biggest things that we and others see in organisms that are exposed, especially the really tiny ones, the zooplankton size organisms, is food dilution. So imagine you're a copepod and you ingest a fiber, and that fiber takes up 25% of your stomach. You're not going to seek prey, or you're not going to be able to absorb as many nutrients from your food. And so not surprisingly, we see reduced growth. And we see this in the lab with particles that we make in-house. And in the Harper lab, since they are part of engineering, they are able to produce particles of specific sizes from products. And so the tire wear I'll talk about today was produced in the lab. Someone basically used a cheese grater on the tread of a tire, ground that up into tiny representative sized particles that you'd find in the environment. And we use those in experiments. And we also try to get down to the really tiny scale, the nanoscale. So something you can only see with a scanning electron microscope, because those are the particles that are thought to be potentially the most dangerous and most persistent, and they behave in kind of unpredictable ways in the environment. So what have we been up to here? And you might see some teeny tiny little dots swimming around in those wells. Those are larval fish. What we do is we look at how fish and invertebrates respond in terms of behavior, growth, and biochemical changes to particle exposure. Specifically today, I'll talk about tire particles. And so we know tire particles are a big deal. And like I said, they're one of the main microplastic pollutants. There aren't a lot of studies locally, although we do plan to start a study in the Columbia River, either later this year or early next year, to look at microplastic contamination coming into the Columbia River. But we know tire particles are released via mechanical abrasion. The leachate is actually deadly to some species like coho salmon. And studies that have been done in the San Francisco Bay Area, as well as the city of Charleston, which is off the east coast of South Carolina, that these are really commonly found in the sediments. They tend to be high density, so they sink out. And so they're probably more of a concern to benthic organisms than some of the organisms we study that tend to be found in the water column. So exposures that we've done here have used representative larval fish and mysid shrimp. Mysid shrimp are really important off the coast of Oregon. Pacific gray whales feed on them, for example. And we use an observation system called the NOLDIS to record the behavior. And then we also measure responses like growth and gene expression. So I'm going to talk about behavior and growth really quickly. So how does a particle affect a fish? Well, it turns out they internalize it, and we can document that using microscopy, as you can see up there. It turns out really interestingly that the salinity affects how much they ingest. And we think that's because the density changes at different salinities. And so from the perspective of a fish or a mysid shrimp, you're more likely to see something as food if it's floating in the water column where you would normally ingest food. So it makes sense. In terms of behavior, and this is just to orient you, this is a radar plot. So the center is the control, and then as you spread out from the center kind of through to the outer corners of that spider web, it's showing you how behavior is changing. And the font is a little bit small, but you can see what happens is that exposure to particles affects things like the angle at which the organisms are turning. It also affects kind of their position in the water column and in their habitat, their little beaker. And so that indicates potentially an anxiety response. And we kind of see those same patterns across lots of different concentrations. So from lower, more environmentally relevant concentrations like 60, all the way up to higher astronomical concentrations because we test across a wide range. And so you see that it's affecting kind of their ability to perceive where they are and potentially affecting their ability to feed. For leachate, we see lower toxicity with the leachate in these species. And what's interesting, and I think this is a really important point to make about all microplastics, is that it's kind of a multiple stressor because the animal is being exposed to the chemicals, but it's also being exposed to the particle. And we try to separate the two to figure out how they're different. And so here you can see it's affecting things like freezing, but it's the patterns are different. So they're differently toxic. And it affects growth. So not surprisingly, the more tire particles a fish ingests, the less it's going to grow. And this is over a really short time period because the fish that we use are only about 4 days old when the experiment ends. So they're basically hatching out into a solution with particles. So, we also test things like fibers. Something important to point out about tire wear is that it includes fibers too. So tires are really complex. They're made up of synthetic rubbers, natural rubbers, as well as fibers to hold that material together to make it more durable. And it turns out fibers cause toxicity too. So we look at things like reactive oxygen species, which are molecules that an animal's cells produce when it's stressed out. And so you can see that the higher temperature and the more fibers they're exposed to, the more of these reactive oxygen species they produce. And just to zoom out a little bit, we've looked at lots of different plastic types over the past few years. And tire wear doesn't always come out on the top, but interestingly, if you look at the highest salinity we've tested at, which is going to cause those tire particles to stay in solution longer, they tend to be more toxic to those fish that feed in the water column at those higher salinities. So where is all this information going? There's some efforts underway in the state of California and elsewhere where they're gathering data from experiments like these and trying to come up with thresholds for monitoring, which is great. And other encouraging things happening at the state level are that there are even discussions about putting legislation into place that would try to limit some of these inputs. So that is really encouraging, and the rate at which kind of change is happening in response to some of these findings is also really, really encouraging. And I'll just end with a little plug for our group and all the wonderful people that have been part of this work, and that we have a consortium meeting coming up on December 12th and 13th, and it will be here, local. So if anyone's interested in attending, check out our website. Registration is free for postdocs and students. And thank you so much.
And we have time for a question. Yes, hang on and wait for the mic.
Great talk. Thank you. I was wondering if your control have any particles in them that would be natural particles rather than tires. So could the response be just to particles?
Sure. Yeah, that's a big kind of discussion in the greater field with folks working on microplastics toxicity. We use NOM, so we use organic matter in all of our microplastics exposure. So there are some sediment particles in the organic matter. It's not going to replicate the plastics necessarily. There's not really a great way to have a positive control for that. But we do include organic matter in our controls. Yeah, good question.
Great. It is now time for our break. We are actually on schedule. And I should mention that this morning's coffee was provided by Sea Grant, and the, yes, yeah, And our break, the food and beverage is going to be provided by Simmers. So thank Francis if you get a chance. And we will return here at 10:55. And if anybody's interested as an icebreaker, we have bingo. Some of you experienced that last night, but it's a good chance to go around and talk to people you don't know and find out which of the squares they can do it. And we have killer prizes for people who black out their square. So I will have bingo right around the door. So please come back here at 11:50 or 10:55. And again, the refreshments are over across the way in the room.
For those folks online, we are going to take a little break from our online presentation and we'll be back again at 1 o'clock or so. So we'll hope to see you then. Thank you.